Okay, today's lesson 6.5, solving radical equations. So a few steps for solving. So to solve a radical equation, first thing you want to do is to isolate the radical or rational exponent. So in some cases, we might have those fraction exponents versus having a radical equation. Once you have that isolated, solve for your variable, and then make sure if you have a quadratic equation, be sure to check both answers. For possible extraneous solutions. All right, so we'll go ahead and I've got 6 examples for us to look at today of solving. So solve the equation. Will be our directions. Our first example, 2 times the square root of x plus 1 equals 21. Okay. So I'm trying to isolate my radical. So here's my radical. So I need to get that all by itself. And I do that the same way I would do if I was just trying to get x by itself. First, I have to subtract. Then I would divide. All right, once that radical is by itself, I need to undo that square root. So I would square it and square the 10. So x would equal 100. And as always with equations, we can always go back, plug that in, make sure it makes sense. So 2 times the square root of 100, add 1, would you get 21? That'd be 2 times 10 plus 1, I would get 21. So you can always go back, plug it in, check your answers. That's the beauty in equations. I know in Math Excel, it's going to spit out whether it's right or wrong, but make sure for your quizzes and your tests, you're plugging that stuff back in. Okay, let's look at another example. Two plus the square root of 3x minus 2 equals 6. Okay, so once again, I want to isolate the radical. So I'd subtract 2. Then I've got the square root of 3x minus 2 is now by itself equal to 4. Since the radical is by itself, I'll go ahead and undo that square root. So I will square both sides. Don't forget to square that 4. So I've got 3x minus 2 equals 16. Notice I did not square anything inside of that radical because I squared the square root, so that undid it. If you squared the things inside the radical, that would mean you squared it twice. Okay? And then I'll go ahead and get my x alone. Divide by 3. So I get 6 as a solution. Once again, go ahead, replace that x with 6. 3 times 6 is 18. Take away 2 would be 16. So 2 plus the square root of 16. Would that equal 6? 2 plus 4 does equal 6. We can always check our answers. For our third example, the square root of 2x minus 3 equals the square root of x plus 5. This time I have a radical on each side, so I can't isolate my radical, but I can just go right from the beginning and square both sides to undo each radical. So it actually looked more challenging from the beginning, but really that just leaves me with what's inside. And then solve for x. So I get an x on each side. I add 3 over. x would equal 8. If I'm checking this answer, make sure you plug 8 in for each x into that original problem. So 2 times 8 would give me 16, minus 3 is 15, 8 plus 5 would give me 13. Let me double check something here. Whoops, 16 minus 3 would be 13. So the square root of 13 would equal the square root of 13. We are correct. All right, our fourth example. 3 times the quantity x plus 3 raised to the 3 halves power equals 81. Okay, once again, I must get my radical, which, talking from our lesson from yesterday, that 3 over 2 is also a radical, right? That would be a form. So I must get rid of this 3 by dividing by 3 first. I cannot distribute that in because that would technically be under the radical. And I'm not trying to take the square root of 3. Okay, so I'll divide first. So then I have x plus 3, still raised to the 3 halves power equals 27. Now, a couple different ways you can work through the problem at this point. You can change it to its radical form. So I can go ahead and write this as the square root of x plus 3 to the 3rd power equals 27. Okay, that would be one option. And then to undo the 3rd power, I'd have to take the cube root, and then I'd have to take the cube root. So now I'm left with the square root of x plus 3. The cube root of 27 is 3. Now I would square both sides. X plus 3 would equal 9, so x is 6. That's one possibility if you want to change that form. The other possibility, this is what I like to do. To me, it's less steps to write down. I like to raise both sides to the reciprocal power. So I'm going to raise it to the 2/3 power on both sides. Because when I raise an exponent to another exponent, what does that mean I'm doing? Well, I'm taking 3 halves times 2/3. So that's 6/6, or 1. So when I do that right here, I've created just x plus 3 to the 1st power and 27 to the 2/3 power. And then yesterday we talked about how you can simplify that. So I can take the cube root of 27 and raise it to the 2nd power, which is what I did on the other side here. I took the cube root of 27, right? I got 3. And then I squared it. So x plus 3 equals 9, and I still get 6. So when you have that rational exponent, you can raise it to the reciprocal power on both sides only when this part is by itself. If there's something in front or something adding or subtracting outside of it, you got to get rid of that first. Or you can change it to its radical form. Either way, work. All right, our 5th example. The square root of 17 minus x equals x plus 3. So this time, the radical that I have is already isolated. I can't do anything else with that. So I'll go ahead and square that side. And I need to square this side, but make sure you use parentheses around your x plus 3 because you're squaring that entire side of that equation. So I will undo that square root. Remember, when I'm squaring something with an addition or subtraction in between, I must write that out twice and distribute. Otherwise, I will get these problems wrong every time. This is not x squared plus 9. Okay, that's going to give me x squared plus 3x plus 3x, then plus 9. So x squared plus 6x plus 9. equals my 17 minus x. Okay, this should bring us back to the end of last quarter. When solving quadratic equations, I need to make sure it's equal to 0. So I'm going to go ahead and add x to the other side and subtract 17 to the other side. So now it is equal to 0. I've got my a, b, and c for this quadratic equation. I can't use square root since I have an a, b, and c, so my options are factoring and the quadratic formula. Okay, every problem that we have in this unit or in this section, you will be able to solve by factoring. So I'm going to use factoring because to me it's quicker. Could you use the quadratic formula and I would not mark it wrong? Yes, you can, but it'll probably take you longer, but if that's the method that you're choosing, that's fine. Okay, but I'm going to factor this. So x times x will give me my x squared. I need two numbers that multiply to -8 but would combine to 7. So that would give me 8 and 1. I need a positive 8 and a -1 to combine to a positive 7. And then remember, you set each factor equal to 0. So -8 would make this true. I should make that look better. -8 and positive 1. Now we must remember to double check both of these answers. It's possible they both will work, and MathXL will say, well, put your comma in between both of your answers when you enter it in, so make sure you do that. But make sure you double check that both of these work in that original problem. We took away the square roots from the beginning. Okay, so we found two things that satisfy this equation. It might not satisfy that equation, so I must double check both. All right, so if I check -8 back into the original problem, I've got 17 minus a -8. That needs to equal -8 plus 3. So this would be the square root of 25 equals -5. Not true. Square root of 25 is 5, not -5. -8 is not part of my solution. So I would not include that in the answer. All right, isn't an extra answer that we got when we solved this quadratic equation, makes this true, but not the original problem true. No way of avoiding it, okay? Up top, I've got 17 minus 1. I'm going to go ahead and plug in 1 equals 1 plus 3. This would be the square root of 16, which is 4, and 1 plus 3 would be 4. So 1 and only 1 would be the answer you would enter in. Okay, so be sure to do that when you get a quadratic equation. Check both. You can have both work, or possibly just one would work. Okay, I'm going to do one last problem. I'm going to do another one just like that. Practice solving a quadratic equation again. If that made sense to you, you can turn off this video and be done. If you want to see one more example, you can go ahead and take a look at this last one here. The square root of x plus 7 minus 5 equals x. This time I will have to get that radical by itself, so I will add 5. Then I'll square both sides. Once again, I'll have to make sure I remember to square that entire side of x plus 5. So I have x plus 7 equals x plus 5 times x plus 5. I will need to distribute. So x squared plus 5x plus 5x plus 25. Combine my like terms, so x squared plus 10x plus 25 would equal x plus 7. We need to get it equal to 0 since we're solving this quadratic equation. So I'll subtract x, and I will subtract 7. Be 18, so that is equal to 0. Then I will go ahead and factor. What multiplies to 18 would become what would combine to 9, both a positive 6 and a positive 3. Set each of those factors equal to 0. So -3 and -6. I need to double check that both of those answers make sense in my original equation that I'm trying to solve. They make sense in this one, but possibly not that one. Okay, so if I go ahead and check -3, replace each x with -3. -3 plus 7 give me 4. Square root of 4 is 1. Oh, sorry, square root of 4 would be 2. 2 minus 5 would equal -3. -3 is a solution. Okay, let's double check to see if -6 works. If it does, we include both. If it does not, we only include -3. I'll go ahead and put it over here. So -6 plus 7 minus 5 has to equal -6. So this would give me square root of 1 is 1. Minus 5 would be -4, not -6. So that will not work. This is my only solution. Okay, that's a wrap on our lesson for today. Let me know if you have any questions on your homework when you are working.